Hello and welcome to my video, lesson 2.2 on trigonometric ratios. So this is a little bit of a different topic, or kind of weird topic for most of you, I'm sure, where you probably haven't heard this stuff before. So this is important. So this is how we can do triangles and find angles or sides when we don't actually have a calculator. So normally you just type in sine angle, cos angle, tan angle, or to sine to the -1, etc. Inverse trig functions. But in this case, we're going to start to be able to do it without a calculator, which is pretty awesome. Not every possible angle, but you can get close. You can do some of the most important angles. So let's start first by reviewing what is tan, cos, sine. What are the different fractions or the ratios that we need to know? Well, hopefully you guys maybe remember hearing this before. SOHCAHTOA, whoops, ink to shape. SOHCAHTOA, and basically the goal here is with SO, that means sine of opposite over hypotenuse. Tan is cos of adjacent over hypotenuse. TOA is tan of the angle over is opposite over adjacent. So just highlighting that those letters there end up showing the three different formulas. All right. So with this triangle here, if our angle is down here at the bottom, as shown, then what are these functions? Right? Well, opposite of the angle is the side that's the furthest away. That's A. Okay, so let's put A here. Let's put A here, and then hypotenuse is C. And then we have the adjacent side is B. Okay, so that's B here, and the hypotenuse is C. So now we have, some idea. If those were numbers, we could put them in for sure. Okay, Pythagorean Theorem is the way that we can find the missing side if we have two out of the three sides, and keep in mind this has to be a right angle triangle. But if we have two out of the three missing sides, then we can find the third. So let's do an example. 3, 5, and we're looking for B. So what would we do? Well, opposite operators to move the 3 squared over to the other side. So we'd be left with B squared on the one side and 5 squared minus 3 squared. Okay, if we were to simplify that or solve that, 25 minus 9. And so now we'd have B is the square root of 25 minus 9, which is square root of 16. So B is 4. All right, so that's Pythagorean Theorem. And now let's start taking a look. Those are all review things. Now let's start taking a look at this year's content. So here we have an isosceles triangle. 45, 45, and 90 degrees are the angles. This you can memorize once you learn it, but if you learn how to get there, then you don't even have to memorize. So let me show you how to get there. Well, the hypotenuse, we're going to make it 2. So on both of our quote-unquote memorized triangles, the hypotenuse is 2. So what we're going to do after we make that hypotenuse 2 is you can actually just use Pythagorean Theorem. So 2 squared equals A squared plus B squared. But in this case, A and B, because it's an isosceles triangle, and because these angles are the same, A and B are actually the same. So 2 squared equals 2AB, or 2A squared, sorry. All right, so now what we're going to do is we notice that we can move the 2 over to the other side. So 2 squared over 2 equals A squared. and we can simplify that to just 2. And if we move the square root over, it's root 2. And maybe let's do that in 2 separate steps. So 2 like that, and if we move the square root over, it's root 2. So A and B here are both root 2. Okay, this is pretty helpful. So this is what you can memorize, 2, root 2, root 2. And the other side is this, these are both special triangles. This special triangle is the 30, 60, 90 triangle. All right, so we can't get there with the Pythagoras, but I can tell you that if you try this, this will be 1, and now we could get there with Pythagoras, and this would be root 3. You can try this in your calculator. So this is how you can test it. You know that it's 2.
Mr. Kelly, can you contact Mr. Cleve in the office at 507? Mr. Kelly, 507.
Sorry about that. You know that this is a 2 for the hypotenuse, and one of the sides is 1. So if you remember just those 2 ones, then you can go 2 equals 1 plus b squared, and then solve for b squared. So that'd be 2 squared minus 1 squared plus, equals b squared. So that would be 4 minus 1 equals b squared. So that'd be 3 equals b squared, which would be square root of 3. So not sure if that helps you remember that a little bit better, but this is the other thing to look for or to notice. 1, 2, 3. So you're literally just, it's 1, 2, 3. So hopefully maybe that'll be easy to remember as well. So root 2, 2. 1, 2, root 3. Okay, so if we were to use these numbers in the sine, cos, and tan functions up above here, right, you can imagine that if we used sine of 45, which is this left-hand triangle, we can get exactly the number that we are looking for. So root 2 over 2. Cos of 45 is also root 2 over 2. And tan, maybe I'll do it over here, tan of 45 is root 2 over root 2, which ends up just going to 1. Okay, so that is helpful. The other side here, the 30, 60, 90 one is going to show us a similar sort of thing. So you can look at the angles here and notice that this one is smaller than this one. So 30 and 60. So if we started at the 60 degree spot, so let's just go with tan of 60. Opposite over adjacent would be 3 over 1. Let's go with sine of 60 is opposite over hypotenuse, and cos of 60 is 1 over 2. And if you do the 30 degree options, all this stuff, you can just look at the triangle and use the SOHCAHTOA rules in order to get these. but I'll just write them out for you just in case. But it's basically going to be flipped version of the 60 degree. So cos is going to be 3 over 2, and sine is going to be, oops, cos 30, and sine is going to be 1/2. Okay, we're doing pretty good. We're doing great. What we need to take a look at now is an example like what you might see on the actual assignment or test. So here, this triangle is asking us to find the exact value for tan theta. Okay, so the exact value for tan theta. And perhaps maybe even we might do another one if we have time. That didn't work very well. Maybe we do like 3, or a different number, 5, 5. And we ask for cos theta. So we'll look for this one as well. Okay, so anyways, exact value for tan theta. Well, what we can do right away is we can look for something that gives us a clue. So the first clue is the size and shape of the triangle. But the second thing is this number is easy to look at and is not like a root of any sort. So that's helpful. And it is exactly half of this number, right? So see how this 1 is exactly half of this 2? In the same way, the 3 is half of the 6. All right, so this is good. So that means we're going to be using our 30, 60, 90 rule. Okay, so here we have our 60, here we have our 30. So what we're going to say is that tan of theta, or tan of 60 in this case, is, and then you could literally just read off of this thing here, or you can remember what the rule is to get to the other side. But basically, 3, yeah, it'll end up being root 3 over 1. Okay, looking at this other one here, we know it's isosceles, and how do we know that? Well, we know it because the 5 is equal to the other 5. Okay, so if those two are equal to each other, we know it's going to be isosceles, which means that we can immediately go to the cos option for isosceles, which is root 2 over 2. Again, that's from right over here. Alrighty, I hope that this video helps you guys understand the majority of trigonometric ratios a little bit better. Good luck.